Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Math 111, Major 2, Term 231. Let us have a look to the exam and solve it together. The first question is about derivatives. Differentiate the following functions. Well, here I have u to the power n, and this is cosh x or hyperbolic cosine. So how to find the derivative of u to the power n? Well, the derivative is n times u to the power n minus 1 times u prime, chain rule. So y prime would be 5 times 3x to the power 4 minus 2x all to the power 4. We subtract 1 from the power times the derivative of u. Derivative of 3x to the power 4 is 3 is a constant. Derivative of x to the power 4 is 4x to the power 3. 4 times 3 would be 12. So 12x to the power 3. And derivative of 2x is 2, because derivative of x is 1 and 2 is a constant. So this is the derivative of u. So this is the derivative of the first term. The second term, if you have plus, then no problem. The derivative works with the plus, fine. 6 is a constant. Derivative of cosh is sinh x. So that's the answer. Notice that if we have a constant itself, y equals to 2, for example, then y prime is 0. Derivative of a constant is 0. But if this constant is multiplied by something, some other function, then we write it as it is, and we find the derivative of the function, which is 1. So the answer would be 2. So you have to differentiate between these two cases, when the constant is alone and when it is multiplied by a function. The second question, find the derivative of this function. Well, I have len, and there is product. There are 3 functions here, product of x squared and e to the power x4 minus 6 and secant cube. This is not, this is a very long question, but I have len outside. Okay, so what if I simplify y first? We know that len uv is equal to len u plus len v. And we know also that len u to the power r is r len u. So we have product here, so we can change the product inside the len into addition by expanding, okay? You remember expanding logarithms functions. So I can write this len x squared plus len e to the power x to the power 4 minus 6 plus len secant cube x. But I have some powers of u. I have x squared here, e. Well, len cancels e because there is a formula that says len e to the power x is just x, so they cancel each other. So I will write it still y as, I didn't take the derivative yet, I'm just simplifying y. So we are still having y here. So this 2, I'll bring it outside, so it would be 2 len x. And len e, they cancel each other, so I have x to the power 4 minus 6. And I have 3 here. 3 is a power of secant, so I can bring it outside using this property. So it would be 3 len secant x. And now y is written in a very easy way, so y prime would be easier here. 2 is a constant. Derivative of len x is 1 over x. So the derivative is 2 over x. Derivative of x to the power 4, 4x cubed. This is a constant alone, so the derivative is 0. This is a constant multiplied, so 3 is there. and we need to find the derivative of len secant. Well, len u, what is the derivative of len u? It is 1 over u times u prime. You can write u prime here or you can write it here. So 1 over secant times the derivative of secant. Derivative of secant is secant tan. So secant x tan x. Of course, I can cancel secant with secant, and the final answer would be 2 over x plus 4x cubed plus 3 tan x. See, the answer is easy and simplified. If you don't expand the len here, it would be a very long question. Here I have a function multiplied by another function. So I have to use the product rule. Product rule says if you have product of two functions and you need to find the derivative, find the derivative of the first one multiplied by the second, then the first multiplied by the derivative of the second. So you find the derivative of them multiplied by the other, and again, the derivative of the other one. That's the product rule. So the derivative of the first function, well, the first function is square root of u. So what is the derivative of square root of u? It is 1 over 2 square root of u times u prime. So y prime would be derivative of the square root 1 over 2 square root of 1 minus 9x squared times the derivative of u. I can write it here or here up. I will write it up. So the derivative of 1 is 0 because it's alone, minus 9. 9 is not alone, so it's there. Derivative of x squared is 2x, so negative 18x. This is the derivative of u. Times the second function as it is, plus. Now the first function as it is, multiplied by the derivative of the second function. Well, this is sine inverse u. So what is the derivative of sine inverse u? 1 over square root of 1 minus u squared times u prime. So 1 over square root of 1 minus u squared. What is u? U is 3x. So u squared would be 9x squared. So if you square 3x, you will have 9x squared. Times u prime. What is u? 3x. Derivative of 3x is 3. So that's the answer. You see that this is cancelled with this one. And you can write the final answer. 18 divided by 2 is 9. So you can write it negative 9x over square root of 1 minus 9x squared times sine inverse 3x plus 3. So that would be the final answer. Using logarithmic differentiation. What is logarithmic differentiation? When we have a function like this, y equals, we start by applying n to both sides. So I write len y equals len tan x to the power 5x cubed. So that's the first step. Then I use the property of len. Len you can bring the power down. That's a very powerful property of len. So I can write the left-hand side as it is, but the right-hand side, I can bring 5x cubed outside, bring it down before the len. And now I finished from this problem. This was in the power, so now it's not in the power. So I can find the derivative of both sides of this equation. Implicit differentiation. Derivative of len y. What is the derivative of len u? We said 1 over u times u prime. So derivative of len y, 1 over y times y prime. Or I can just write y prime here. What about the right-hand side? I have function multiplied by another function. So I have to use the product rule, this rule. So derivative of the first function. 3 times 5, 15 x squared times the second function as it is plus the first function as it is times the derivative of ln u. What is the derivative of ln u? This is the derivative of ln u. 1 over u times u prime. So 1 over tan x times the derivative of tan, which is secant square x. So this is the derivative of the right-hand side. Finally, he's asking about dy by dx. dy by dx is y prime. So I must get rid of this y. So I can multiply both sides by y. Both sides I'll multiply. When I multiply by y here, y cancels with y. So I'll have what? Y prime equals all of this, which is 15 x squared ln tan x plus 5x cubed secant square over tan x. All of this times y. But what is y? This is y. So I'm writing y as tan x to the power 5x cubed, and this would be the derivative. This would be dy by dx. For the given curve, find the following. The equation of the tangent line to the curve at the point 2, 1. So what is 2x 0 and 1 y 0? And the equation of the tangent line is y minus y 0 equals y prime or dy by dx at x 0, or because this is implicit differentiation, it would be y prime at x 0 y 0 times x minus x 0. So I need to find y prime. Well, this is implicit, so let me find the derivative. Derivative of x squared is 2x. And here I have product. 2x, the first function, y is the second function. Use the product rule. Derivative of 2x is 2 times the second function plus the first function times the derivative of y, which is y prime. Remember, in the implicit differentiation, derivative of x is 1, derivative of y is y prime because y is a function of x. So plus derivative of 4y squared, 2 times 4, 8y, so this is the derivative, times the derivative of y, which is y prime. So whenever you find the derivative of y, you multiply by y prime. That's the chain rule. Y is u in the chain rule. So because y is a function of x. So it's, for example, y is a function of x, f of x to the power 2. So to find the derivative, 2 times 4, 8f of x, which is y, times the derivative of f, which is y prime. This is how we find the derivative, how we use implicit differentiation, or how implicit differentiation works. Derivative of 12 is 0 because it's constant alone without not multiplied by any other function. Now, x is x0. I can replace x here by 2 and y by 1. So I'll have 4 plus 2 because y is 1 plus 2 times 2, 4y prime plus y is 1, so 8y prime equals 0. So 4 plus 8, 12y prime. 4 plus 2 is 6, and I'm going to take it to the other side. So y prime would be negative 6 over 12. You divide both sides by 12, which is negative half. So that's the slope. This is y prime at x0, y0. So the equation of the tangent line would be y minus 1, which is y0, y prime, which is negative half, times x minus 2, which is x0. That's the equation of the tangent line. He's asking about the equation of the normal line. Well, the normal is perpendicular to the tangent. Normal and tangent are perpendicular. If tangent is like this, tangent to the curve, then the normal would be perpendicular. So we found the slope of the tangent, -½ So what would be the slope of the perpendicular line? We just find the reciprocal and multiply by negative. So -½ what is the reciprocal? 2 over -1 multiply by negative, so it would be 2. So when you multiply -½ times 2, you will get -1. And that's the relation between the perpendicular lines. The product of their slopes is -1. So you find the reciprocal, you flip -½ it would be 2 over -1, which is -2, and then you multiply by minus. So that's the answer. There is no change in the points because both lines, tangent and normal, pass by the point 2, 1. Only the slope changes. Verify this identity. Well, what is sine 2x? Oh, sinh 2x, hyperbolic sine. Well, the definition of hyperbolic sine is e to the power x minus e to the power -x over 2. So sinh 2x means we replace x by 2x. So it would be e to the power 2x minus e to the power -2x over 2. So to prove the identity, I'm going to start from the right-hand side, this side, because I have a lot of things to do. I can work with this side. So I have 2. I can write the definition of sinh, which is we mentioned here. And I can write the definition of cosh, hyperbolic cosine, which is the same but with a plus in the middle. And now let us think how to simplify this. Well, I have fraction multiplied by another fraction. So how to multiply two fractions? We multiply the numerators over the denominators. This is a very important formula. You need to understand it well. So I can cancel this 2 with this 2 if you like. And now multiply this times this. If you multiply these two, this is u minus v and this is u plus v. When you multiply u minus v times u plus v, you get u square minus v square. And this is again another important formula. So we get e to the power x times e to the power x, which is e to the power 2x, or e to the power x square. And then we multiply the powers, so we get 2x minus square of e to the power -x, which is e to the power -2x, over 2 times 1 is 2. And what is this? This is in fact sinh 2x, which is the left-hand side. So this is the proof of the identity. Find the limit. Well, I have formulas. We have formulas for the limits. We know that limit sine x over x when x approaches 0 is 1. But I do not have sine x here. I have sine x minus 2. And x is approaching 2, not 0. If you look below in the denominator, you have x squared minus 2x. So you can take x as a common factor. And then you will have sine x minus 2 up over x minus 2. Using this formula, if you have AC over BD, you can write it A over B times C over D. So I can write this as limit x approaches to 1 over x times limit x approaches to of sine x minus 2 over x minus 2. So this one, I wrote it like this multiplied by this. If you multiply these two, you go back to this one. Now the limit, the first limit, if you replace x by 2, so the answer is 1, is half, 1 over 2. But what about this limit? What is the limit of sine x minus 2 over x minus 2 when x approaches 2? If you replace x by 2, you will have sine 0 over 0, which is 0 over 0. So in fact, this formula is exactly this formula. So if you take, for example, if you call x minus 2, if you call it u, then this limit would be what? Would be limit sine u over u, because x minus 2, I called it u. And now when x approaches 2, what happens to u? It would be 2 minus 2, which is 0. So in fact, this limit is exactly equal to this limit. And this limit is 1. So this limit is 1. And the answer is half times 1, which is half. So that's the answer. A cylindrical tank with radius 4 meter is being filled with water. So there is a cylindrical tank. We are filling it with water. The radius is 4 meters, radius, at a rate of 2 meter cube per inch per hour. So what is this? What is 2 meter cube per hour? Being filled with water at a rate. Rate, what is the meaning of rate? Rate means derivative. So rate means dy by dx. What is y and what is x here? Well, what is changing here when you fill the water? The volume of the cylinder is changing and the height of the water is changing. Notice that the radius of the water is not changing here. If you fill it with water, I reach here, for example, so the height would be here, then the height would be here. The height and the volume of the water are changing. So this is the rate of change of the volume, and the volume is called V. So in fact, dV by dt is 2 meter cube, because the volume is in meter, and the height, the time, sorry, is in hour. So 2 meter cube per hour. So this is the change, the rate of change of the volume with respect to time. How fast is the height of the water increasing? Yeah, he's asking how fast means also rate of change. What the height? So he's asking about dH by dt. What is dH by dt? What is the rate of change of the height with respect to time? So V and H are changing. I need a relation between them. He gave me the relation. But notice that R is not changing. R is 4, always 4. So the formula would be, I replace R by 4. So it would be 16 pi H. Because R is fixed, it doesn't change. But V and H change with time, with respect to time. So now I find the derivative with respect to t of both sides of the equation. So dV by dt, derivative of V is V prime, which is dV by dt equals 16 pi is a constant, and derivative of H is 1 times dH by dt. Now dV by dt is 2, given in the question. 16 pi is a constant, and I need to find dH by dt. So what would be dH by dt? It would be 2 over 16 pi. We divide by 16 pi, both sides. So I'll have d 2 over 16 pi, or 1 over 8 pi. That's the answer. H measured by meter per time measured per hour. So the answer is 1 over 8 pi meter per hour. This is the rate of change of height with respect to time. Now the equation here is given, and x, y are functions of t, so they are changing with respect to t. dy by dt is given, dx by dt is given. When x is 2, no, we need to find dx by dt. dy by dt is given. Find dx by dt when x is 2 and y is 1. So I need a relation between x and y because they are changing. Well, the relation is given, not like here in the question. Here also the relation was given, okay? He gave it to you. So let us find the derivative of this equation with respect to time. What is the derivative of 4x squared? 8x times what? Times dx by dt. Chain rule plus, because x is a function of t. What is the derivative of 9y squared? 18y times what? dy by dt. Derivative of 25 is 0. So x, what is x? 2, so 8 times 2 is 16. dx by dt, I need to find it. What is y? Y is 1, so 18 times 1 is 18. What is dy by dt? 3 equals to 0. So what would be dx by dt? 3 times 18 is 54. If you take it to the other side, it would be negative 54 divided by 16. Or if you divide by 2, negative 27 by 8. This is the dx by dt. And this was the last question. I hope you enjoyed watching the solution of this major, and I hope you do well in the major.